Today we won't be working on the compiler itself, but on something that is much more interesting and fascinating. We will write some documentation, because we just have our compiler and it is the only example how the programming language looks, but we do not have any other description. I actually already documented the syntax of the language, so I will use the AsciiDoc for the documentation. I have a choice between TeX, LaTeX, and AsciiDoc, and I decided to go with AsciiDoc because it is something easier to read if it is not compiled, and it is supported by a lot of viewers, and a lot of people are familiar with Markdown, and it has some similarities with Markdown. So I already created a document in the in the doc directory, and we open it. So the AsciiDoc compiler, so to say, is written in Ruby, and I already use rake for the compilation and building. So I added a new task, rake doc, that generates a PDF document for this documentation. So we open the PDF, and I only copied an introduction from the README, and added a syntax description for the whole language. The syntax description is EBNF. It is not the classic syntax for that, so I use the notation created by Niklaus Wirth, because our language is basically a language in the family of the Wirth's languages, and it has a lot of ideas from Oberon. So I decided to use his notation that is used in this specification of languages like Oberon, but also Golang uses it too. So we just have a lot of rules on the left side, and we say what is a rule, what are components of a specific element. For example, integer literal is a digit followed by any number of other digits. So these curly braces are repetition. Then we have options in here. So a letter is A or B, or for example a literal is integer literal, or word literal, or real literal. But for the most part you just write the components of element in the row. So for example, a field is an identifier followed by a colon and followed by a type, and this thing describes basically the whole grammar. It is not the final grammar. I probably will experiment with some things and change grammar a bit, but I think that it pretty well describes the language. The current compiler can't everything that is in this document, so it documents not the currently implemented language, but a bit more, so we still need to implement some things from here. The one thing that is missing is go-to declarations and label declarations and go-to statements, and we are going to add them now. Somewhere I had a statement block with statements, and since label declaration is kind of a statement because it does appear, it doesn't appear in the declaration block but in the statement list, so we can just call it label declaration. Label declaration is just a period followed by an identifier. And now we have this statement block, so I put it in front of the statement, and another statement kind is actually this label declaration, or let us put it on a separate line because we will have a go-to declaration here and go-to statements. Go-to statement is go-to keyword followed by an identifier, and we can then we can add the go-to statement too. And we compile it, and it should already appear here. So this is done. Then we need different sections for the parts of that grammar that describe particular things. So we will have, for example, sections for if statements, while statements, and so forth. We can have something like conditional statements or loop statements. Conditional statements. Loop statements. And we can copy parts of the grammar into these sections. Also now another section would be type system, And we can actually begin with the literals. So literals are base types. So what is missing in the grammar is, for example, our primitive types. So we can list the types that we are going to have. This will be a pointer, this will be a word, an integer, a boolean, a string. I won't provide I won't provide full description today. We just need to get the main elements so that I can add more information with time. But I want just to have a basic structure I can work with later. I think actually, so we have characters as well, and that's it. I'm also going to have something like byte, but I am not sure how it will be called, because I probably will have things like word 8, int 8, word 16, or I can call them something like half word, long int. I'm not sure what the naming will be, so I'm going to skip the byte type for now. But I think this is actually the basic types that we have. Type system is actually pretty, yeah, built-in types probably. So let us look. Interesting. How can I do nested lists? No, this is not the way. So the documentation says that the lists are written with asterisks, and that for the nested items we just need 2 asterisks. Yeah. So then we have pointer types. Then we will have static arrays, and we will also have procedure types. Or function types, pointer types, procedure types. Exactly. If something is missing, of course we will have records, and we will have enumerations. Yeah, I probably should have subsections for this stuff, so we revert this change, we make it primitive types, and this is the primitive types, and we create then a subsection for other types. So pointer types, static array, procedure type, record, and enumerations. Let us provide some examples for the pointer type. So a pointer type is designated with a head before the type. So for example, a pointer to a word will look like pointer to a word. And when we have a pointer to a word, we can dereference it to get the word that the pointer points to, and the dereferencing works with the head symbol as well, but on the other side. So if we have a variable x of type word, then we can access this variable with x and head. This is actually an almost valid program. The thing would just end with dot, and we have a program at the beginning, and then this is a valid program. What can we do? But it is we can assign just some value to it. So we can say that this thing equals 0. This would be one example, and probably we can also add the pointer taking operation in the example, or probably not. This will of course crash because x is not defined. X of type word, y of type pointer to word. Then we say that y equals address of x, and then we assign to that value now 0. So this seems to be a better example. So we have now one example for for the pointers. Another thing that isn't actually implemented at all are static arrays. So static array is just, or let us call it array, will have its length in the square brackets in the front of type. So if you want to create an array of 10 words, we write it like this. It is actually the syntax from the Oberon Plus. The full syntax would be array of what, something like this. Yes, exactly. I think this is the syntax. Array with 10 elements of type word, and we shorten these to just brackets and the word, because first time I've seen the syntax, I've thought why do we write the length of the array in the front of the type, and the explanation is actually that this was the full syntax used by Wirtz languages, and if we remove some keywords that we do not need for parsing anyway, then we get this short form. So we have here an array. Let us give it 3 elements. We probably will also have array initialization so that we can assign, or let us go with ints, and here as well. One, 2, and 3. And then we can, for example, assign values from this array, for example. And another thing that I want to do, I want to have arrays that are 1 base and not 0 base. So the first element of an array will be not 0 but 1. And we can assign, for example, second element to the first element, terminated listing block. Yeah. So this is an array example. Then we have procedure types. So let us define a procedure. For example, f with 1 parameter and return type, int as well. And let us define a variable a, which will have the type of this procedure. So we will write as procedure, then argument types, and then the return type. Since we do not have any statements in the procedure, we can skip the begin and in our program itself we can then assign this procedure, this f, to the variable we can assign the procedure f to the variable a, and then we can call it, for example, with a 0. This is the syntax for procedures. Then we have records. So let us define a type T, and it is a record, and it has a type X, a field X of type int, and we will define a second type U, and this U type is also a record with the base type T. We add also some fields to this type, for example y of type int and set of type int. Base type just means that this U record inherits the fields of T. So basically this record is the same as X int, but we can just inherit the fields from T by using it as a base type for the record, and probably it will allow some automatic conversions. So for example, that we can cast the pointers of one of a child type to the base type implicitly. So this is the idea here, and I can actually define a variable of type T. Let us call it now of type U. Let us call it small u, and then I want to have a constructor syntax for the records, so that I can say U and then set all the fields in the record. So first X, then Y, and then Z. And I can assign specific fields of the record. For example, I can say that UXX is 3, for example. Here it should be 2, of course. So this is the idea with the records. And let us add an example for the enumerations. We also define an enumeration type E, and its elements will be 1, 2, and 3. And then we define a variable small e of type E, and we begin the main program body, and basically we then can say that E is, for example, E1. So that's it here. I should probably say that this is an example. If I just write it here, how will it look? Yeah, I think it's fine. I wonder if I can provide some information to these code blocks. Probably not. Okay, we let it be. So just let us put example here everywhere. Example, 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 and example here. I should probably write what the program does instead, but for now we just put example everywhere. So that's for the type system. Yeah, we have some grammar that should be explained separately, what our tokens look like. Another thing are, for example, the operators, because the current expression grammar is split in different production rules, so we can have precedents for the operators, but we also should document these precedents in a kind of table. Loop statements, conditional statements. Yeah, let us just add a section expressions. And we put a precedence label in here for the binary expressions. Okay, so we write a period and then we write operator precedence, so it is the table title, and then we have this thing here, and then we can define the columns. I think column 1 header row, column 2 header row. I will just write the example from the AsciiDoc documentation. The format is of course AsciiDoc, not AsciiDoctor. AsciiDoctor is the thing that parses it and generates PDFs and such. I got it wrong in the beginning. So header row, then we run again column 2 header row, and I would say let us just see what we get. So we have to finish. I have to finish the table. Now it will probably look something better. Column header row. Yeah. I think we actually probably need only two or three columns. So the one column is, so it shows column 1. Okay, this is what appears in the header. We can just call it precedence. The second thing is the operator, and we probably need a third column with description. We don't have right to left associativity, so all things are handled from left to right. Description, yes, that's probably it. Then to define the columns itself, I actually just put them here. Probably I can have a new space here, and we can just write something like plus or something. No, precedence first, then we write, for example, plus, and then we say that this is addition. How will it look? Yeah. Okay, that looks fine now. Precedence, we need our binary expressions. Let us begin with the operators. We do not need the unary operators, only binary operators, and we just paste them here. So how are they splitted? We have relational operators. All relational operators have the same precedence, so we can just put them all together in one of the rows. And does this thing has something like comments? Doesn't matter. But we can put this thing under the table so it doesn't mess up the formatting. Drop in cells from common row detected, end of table. Ah, I see, of course. They are separated with a pipe. We can just separate them by a space, or probably even better, by a comma. That looks not really fine. What if I change the order of these two operators? Yeah, it looks a bit better. So this is relational operators, and as description we can write that these are relational operators. Then we have multiplication, And multiplication has actually a higher precedence. Multiplication has the highest precedence in our case, I think. So we can put addition, and addition goes after the multiplication. So we paste multiplication here, say that its precedence is 1, and we write then the operators, and then we list the operations. So it would be then multiplication, division, and remainder. So we have this one. Then we can finish addition, and subtraction. So this is done as well. Plus, minus. Relational operators, then this can go, and we only have the shift operators. I wasn't sure about the shifts, but I just copied the precedence of shift operators from C, so they basically go directly after the addition things. So we have then left shift and right shift here, and we can write that these are left and right shifts. And I think that the compiler is unhappy. What about this? I don't know. The both variants look bad. So I'm pretty sure it is everything. So we have these relational operators. We always have space, at least in the official examples, there is a space in front of the pipe, but no space after the pipe, and we are going to do it the same. I hope it won't break anything. So plus multiply, plus minus, shift, and relation. Logical operations I'm missing, of course. So the last category, and they are the weak. They are the weakest. So 5 would be OR, XOR, and this is 5, and we call them logical operators. And I think that's it for this table. we only need the binary operators here. Then we have two cases with the unit operations. We have designators. Designators go always after the expression. We have unit expressions. Unit operations are always in the front of the expression. And for example, if if we take an address of the variable, for example R, and R is a record, or record is a keyword, let us call it R and field. Here we have multiple expressions. So the one expression is basically, these are two or three expressions. The one expression is variable expression. This is this R. The second expression is field access expression. So it has an expression on the left side and then field name on the right side. And the third expression is address taking expression. And this is actually the precedence. The operators, the postfix operators like field access, they have higher precedence and they are evaluated first, and the prefix operators have lower precedence, but otherwise everything is evaluated from left to right in the both in both cases. One second. Includes three expressions. The first one is variable expression R. The second one is field access. We put R in the parents and write field, and the third expression is basically address taking. So like this, we can put it into the backticks and try to compile this thing. Okay, we can remove the parents here, so it is actually readable what it is. And basically this error, this is a variable expression, Such variable expressions are called simple expressions, probably, or maybe not. Simple expression term, simple expression is more complicated. Selector. Reference designate is also a more complicated expression, and designator includes the reference, so they basically refer to each other. But basically, such a simple expression like R can be a literal. It can be also trait, cast expression, or procedure call. Or it can be a nested expression. So the expression is evaluated in the above order. The postfix expressions like field access have higher precedence than prefix operators left access have higher precedence than prefix operators. Yeah, that's enough as first information. So what we can do else? Static arrays documented. So I would say let us document the types. So we have an example, but we will put also the grammar here. So for the field, we do need a field definition and record type definition. Exactly. Then For the enumeration, we need the enumeration type, and that's it, because it's just parents with a list of identifiers. The type, so this is enumeration. Let us remove the empty lines first. Okay. Enumeration type. Then we have procedure type. Do I define it? I think this one, yes. Followed by a return declaration. So this is procedure type. And we can put the return declaration in here, but it also used in other places. Here we can put the return declaration here. So it is this one. Then we have array and pointer type. Let us find them. This is the static array. So and this is a pointer. And we can put the type declaration here. We can also provide other elements of the procedure declaration in the section about procedure types. Actually, that isn't bad, I think. Procedure. Let us put it here as well. Return declaration, procedure type. Block is the body, procedure body, and procedure heading. So that's it. Let us list the available operators. I don't know if it should be a table or some kind of a definition list, but I do not know whether AsciiDoc has something like a definition list. Probably not. So what operators do we have? These are binary operators, and these are unary operators. And we will then have the operators used by the designator. It's actually array access, pointer, dereferencing, and something else probably. Designator, designate expression. It's selector and field access. And field access. All of them can be described in other places about array types, about record types, and about the referencing. Selector is actually used also for the enumerations. But well, let us describe the unary operators as well. So let us see what AsciiDoc does with this list. Yeah. We will just write a paragraph for each operator. It's probably the easiest way. So takes an address of its operand. The operand expression should be addressable. One sentence. Unary expressions are expressions with one operand and prefix with a prefix operator followed by one operand. Takes the address of its operand. The operand expression should be addressable. So minus negates numeric value. And tilde has actually two meanings, and I think that often the languages use two different operators for the logical NOT and bitwise NOT, but since we have a type system, why do we have to do it? We can just use we can just distinguish between the types and use the appropriate operation for that. So basically, apply if this operator is applied on a boolean, then it acts as logical node, applied the numeric value let us put apply to a numeric value as bitwise node. This is actually how it should work. Apply to a boolean. So logical node applied on the value is bitwise node. I think this is a bit too long. Yeah, let us put it in here. So this is fine now. It is not that well readable what this operator is, so we can write just the name of the operator, and this one is I still don't like it that much. Can we make it bold on something like this? This is not, oh, this is bold. And if I make this thin bold, yeah, it looks much better actually. I don't know. And for minus, it is still too small. Yeah, I don't know. Let us just write this in bold. And probably we can do something later. This is for designate expressions. This is only for binary expressions. This is not only for designate expressions, this is also for unary expressions, but we probably should swap them so the sections goes after the unary expression. I have no idea. Let us be it as is. we have then designate expressions, but we won't describe them here. And then we have this thing, with cast expressions and traits. Typecasts almost belong to the types section. Procedure type, records. Type system, primitive types. Let us copy the cast expression syntax. So we copy this one, and then actually the traits belong to types as well. So we go to the end and define a new section, type operations, and then we copy the grammar here. The type of an object can be reinterpreted with a cast expression. And the cast expression looks like this: cast value, or let us call it object, new type, object team, this expression forces actually just the type, or we can write type here, or target type. Not all values, not all types can be casted between each other. There will be some rules, but we will leave it as is now. And for the traits, allow this is just so cast and traits. And trait identifier is actually can go into here as well. Traits allow to query some information about the types, like their size. Threads allow to query some information about the types, like their size or field offset, or field offset or alignment. These are actually the three operations, the three traits that we will support. So like the size of field offset, this calling traits looks like procedure call. Calling a trait looks like a procedure call, but traits names start with the hash sign, and their arguments are type expressions and not just expressions, and not value expressions. Let us call them it. So the three supported traits are size of t. The second one is align of t, and the third one, actually offset, field alignment will be offset of. How is this C operator called? It is offset of, I think. Offset of. Yeah. Type and member and line of. A line of type ID queries alignment requirements of a type. Yeah. So, and then we have this offset, and it has type T and F queries type size. Queries type alignment. Queries the offset of type of the field F in the record T. There is still a lot of stuff to document here, and this won't be the last edit of this document, I hope. So as I continue to write the compiler, I will provide more information and try to provide better explanations and better documentation for the compiler, at least the official things, so that everything that the language can is documented. But for now we will stop here, because I already have done some work and we have at least the basic elements documented, so there is a place to look up the information about the language, and we will fill it slowly as we go with the development of the compiler itself.